A steel container of volume 0.55 contains hydrogen gas at a very low pressure. 10 to the minus 6 atmospheres. So actually 10 to the minus 6 atmospheres, what would that be? 10 to the power minus 6 times 1.01 times 10 to the power of 5. So the pressure works out as being 0.101 pascals. The temperature is 300 Kelvin. How many moles are in this? Good old PV equals nRT. So N is PV over RT. So P times V divided by R. Last it's gone. Alright. P times V divided by R divided by T. It's really small, yeah? I got 2.2 times 10 to the minus 5, basically, yeah? Now, how do we get the number of molecules? Well, we just multiply that by Avogadro's. What number is Avogadro on the calculator here?
6.0.
No, we'll get the constant of 24. Yeah, right, that's part A. B now. A steel cylinder for storing gas at high pressure contains helium at a pressure of 180 atmospheres. So that's 18180000 pascals. Write that near 0000. Temperature is 300 Kelvin. The maximum safe pressure is 350. What is the maximum safe temperature? Okay. So this is like at the beginning, and then what happens is they increase the pressure to maximum, which is 350 atmospheres. So the pressure will be 35350000 pascals, and the temperature they want to know. So in other words, when you increase the pressure here, what's the change in the temperature? Yeah, you can do it this way. I mean, we have a law for it. But I think the way I like to do it is I'll write down the ideal gas law. So you have PV equals nRT. Now what's constant in this situation? Well, the volume, the R definitely, the number of moles definitely, because it's in a container, and because it's in a container that's not changing its shape, the V is constant. So you can say that P over T equals NR over V. So since this is not changing, you basically get the result that pressure and temperature at the beginning equals pressure and temperature at the end, which in fact is one of the laws I gave you when we did temperature, when we did materials. So at the beginning, which one are we looking for? Here, the T2. So you can just rewrite that as T2 will equal P2 over P1 times T1. So P2 divided by P1 times T1. So I got this really large number, 583.3 kelvins. So that's the temperature you can raise it to get the maximum pressure. Last part. So what's the last part there? Give a reason why you think high pressure cylinders are tested with water rather than gas. So why do you think you test the pressure of your cylinders using water instead of gas? Any ideas? Yes?
Better pressure.
No. Guys, look up here.
High pressure.
No. You're complicating it. Think simple. If you want to see what the maximum pressure is in your cylinder, why would you fill it with water instead of gas?
Because you can see it.
Good. So you can see it. But when would you see it?
When it. What are we seeing again?
You can see it if it is leaking. Right? Gives another reason. Guys, come on, simplify it.
You can see the changes.
What changes?
Temperature.
No, you can do that with gas too.
Easier to get the temperature.
Can stop
Possibly.
more amount.
Possibly. Hey, look. Think about this. If your tank explodes, do you want dangerous gas flying into your face at high pressure and temperature, or would you prefer, hot water? Yes. Right? I mean, your choice is between getting sprayed in the face with hydrogen or with water. Your choice. Which would you pick? So, firstly, it's a safer material. It's not poisonous. It's not harmful. Okay? So, water is a safe material. Oops. And I think a very, very important practical reason that water is free. If you're going to be testing tanks, and tanks sometimes fail or explode, you don't want expensive gas being lost. A tank of helium will be maybe 500 or 600 euros. When you see the people filling up the balloons with a tank of helium, I think those tanks are about 5, 6, maybe even 700 or 800 euros. So if that was leaking, if it was broken, you don't want to lose 700 or 800 euros of gas. So there's 3 good reasons I can see why you would use water instead of a gas for testing the tanks. All very good reasons. Okay.